For this example, we want to approximate the area under the graph of y equals 9 minus x squared over the interval from minus 2 to 2, with 4 rectangles using both an upper sum and a lower sum. So first we have to draw a graph of this function to see what it's going to look like. This is going to be a parabola facing downward with vertex at 0, 9. If we want to go from minus 2 to 2, that's going to mean we have to cut the area off here at minus 2 and here at plus 2. So that inside what we want to find the area of. If we're going to use 4 rectangles, we're going to have a width 1 rectangle at each spot, because the width should be 2 minus negative 2 over 4, which is 1. So we'll have another line here at minus 1, the axis at 0, and the line at plus 1. Now, for an upper sum, I want to, on each small rectangle, pick the maximum value that I can for the height. That's going to involve a height for this first rectangle being at minus 1, the height here coming from the value at 0. For 0, 1, I also get the height over at 0, because that is the biggest value on that interval, and then that for the other one. So that's the upper sum there in purple. And for this, we get an area of 1 for the width times f of minus 1, plus 1 times f of 0, plus 1 times f of 0, plus 1 times f of 1. And it is okay to pick the same point twice here. That only happens because that 0 is at a vertex, and it's the maximum value for both of the adjacent intervals to it. In this case, this is totally fine. We can then work out this sum. F of minus 1 here is going to be 9 minus 1, or 8. So we get 8 plus 9 plus 9 plus 8, which is going to be an area of 34. Now for a lower sum, I want to take the lowest possible height on each little rectangle. That's going to involve a height here, 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 and here for this setup. Picking the minimum point on each little interval to make the height. So for a lower sum, we're going to get 1 times f of minus 2 for that first rectangle, because the value at minus 2 determines the height, plus 1 times f of minus 1, plus 1 times f of 1, plus 1 times f of 2. Notice here we've skipped 0, because 0 is never the minimum value on a little interval, because it's the maximum value of the function. This then gives me an area of 5 plus 8 plus 8 plus 5, because f of minus 2 would be 9 minus 4 is 5. And that has an area of 26. So I get 26 for the lower sum, 34 for the upper sum, and those both give me approximations to the area of this region. I know it's somewhere between 26 and 34, but unless I do a different approximation, this is the best I can get for getting an idea of what this area actually is under the curve for this function.